Hello and welcome to Cup of Cosmology, the place for all your questions about the universe. My name is Diana Hooper and I'm a postdoctoral researcher currently at the Helsinki Institute of Physics over in the University of Helsinki in Finland, where I study theoretical physics and specifically I study cosmology. So that means that I study the universe, the contents of the universe, how everything revolves, how everything interacts, all of the cool things happening inside the universe. I really like being a scientist. I like being a cosmologist. Studying the universe is an amazing thing to do. And I really enjoy chatting to everyone about all of the cool things happening inside the universe. So, hey, David Dunn in first. Great to see you as always. Always nice to see you coming in every single week. So, yeah, I like chatting about space, about the universe, about cosmology, about my research, about academia. If you want me to add, hello, David Howden. Both Davids in the room now. Nice to have you both here as always. So yeah, I love chatting about science and cosmology and what I do with my life and all cool things. So this is what Cup of Cosmology is for. This is a place for you to ask any questions you have about space, about cosmology, about the universe, about dark matter, about black holes, about time. Anything you want to ask, this is the place to do it. And I will do my best to answer your questions. Hey, Scott, great to see you as well. Another one of the regulars tuning in, as always. So yeah, I love chatting about the universe, wherever you're watching from. If you're on Twitter, welcome. Great to have you on Twitter. If you want to join in the conversation, you should head over to YouTube. On YouTube, you can actually ask questions and comment and interact with everybody. But if you want to just lurk on Twitter, that's also perfectly fine. If you are watching on YouTube, please do like the video, leave a comment, click the subscribe button if you haven't done so already. All of this does help me build the engagement. There has been a surge of activity on my channel in the last couple of weeks, so thank you to everyone who has been spreading the word and liking and subscribing and sharing the links. I do appreciate it. We are gradually rebuilding after leaving HAPS and kind of losing all of my community on HAPS. It is very nice to see you all follow me over here on YouTube or on Twitter, wherever you're watching from. It's great to have you all coming over and joining the conversation as always. Hey, Paul, great to see you. Nice to have you in here as well. I'm sure you'll all have great questions for me as well. And David, how am I and how is Finland? Oh, big questions. So I am doing well. Let's go with, yeah, I'm doing well. Thank you for asking. It's kind of a busy time for me right now, slightly stressful time, but overall I am doing well. And as for Finland, Finland is amazing. You know, actually, yesterday was exactly 1 year since I moved to Finland. So 1 year exactly that I've been living in Finland. And I've loved every part of it. This is an amazing country. There are great people here. The group that I work in is really nice. The place is really good. The research being done is great. The city's so pretty. There's so much nature around. It's so quiet. You know, it's my favorite place. I very much decided that Helsinki is my favorite place to be. So I'm very happy that I am here in Finland and enjoying Finnish lifestyle. Now, of course, there's always ups and downs, as in any country. There's a few minor things that bother me, as anywhere, but overall, it is my favorite place. So I am doing okay, and Finland is great. Thank you for the question, David. Currently packing to move house. Think the weight that you call dark matter might be all the junk I've built up over the years. Yeah, I feel you, David. Anytime I move country or place in general, I wonder just how I was able to accumulate so much stuff. Because you know, we just accumulate stuff and then you move and suddenly it's like, where did all this come from? You know, when I moved between Vienna and Germany, I moved with 5 suitcases and that was it. It was one trip, everything fit in 5 suitcases. And then I did the trip like 5 years later between Germany and Belgium, and it was like 5 train journeys with suitcases, a whole car loaded up with stuff. And then when I moved up to Finland, it's just like I'm just getting a moving company to move all my stuff because it's just so much stuff. Always wonder where it all comes from. And yeah, maybe dark matter is all the junk that we didn't realize we had until suddenly we're moving country or moving house. And then suddenly you have too many books and too many board games and too much of everything. And you can't get rid of anything, of course. Walking down 2nd Avenue sounds fancy. I have no idea which is 2nd Avenue, but I guess it's the second one in a very logical system. Get to the cafe, ask me questions. You know, that's a cool setup. To go to a cafe, ask questions about cosmology. I like that. Dark matter is all the stuff that is behind our couches. Yeah. The lost, invisible stuff that's there. Yeah. Yeah, so today is an Ask Me Anything. The reason being, as I mentioned at the beginning, I'm slightly busy these days, which means I don't really have time to prepare topics. So rather than deciding not to do anything this weekend, I thought I would just come and do an Ask Me Anything. So I don't have I don't have any topic prepared. The idea today is that you can ask me anything you want about the universe, about cosmology, about academia, about my life in general. You can ask away, and I will try to answer your questions. As for blue dwarfs, we've already covered that. I did bring on a guest specifically to cover blue dwarfs so that you would stop asking me, Scott. So blue dwarfs are super fun stars that are hypothetical, older than the age of the universe. Very cool. Go watch the video where I had an astrophysicist come on and discuss stars, because I just realized that video is not on YouTube. Huh. Okay, next time I upload a video to YouTube, it will be the one where blue dwarfs were discussed, because that one I downloaded from HAPS, but I have not yet put on YouTube, so that is a good reminder. Comment from Paul: I've been noodling on how to use gravitational waves to study dark matter ever since you dropped a hint about it last week. Yes, I did just kind of drop that hint and then walk away from that conversation. I'm not going back to that today, but I do plan on going back to that at some point. It's a fun idea, it's a fun topic, and I will come back to that, but not today. But yes, can we use gravitational waves to probe dark matter? That's an excellent question. Okay, comment from David Howden. Electrons have negative charge, protons have positive, equal and opposite. Any fundamental reason why they are equal rather than an electron being different than the charge of the proton? Is there any fundamental reason for that? I mean, it's nice because things will then work out pretty nicely, right? Then we have positive and negative that attract. Is there any fundamental reason for that? There might be. Is there? Is it to do with how the photon interacts? I am not sure. That is a great question. I could justify that answer in either direction, which means I should justify it in neither. Like, I could say yes because, and I could say no because. So in that case, I'm not going to answer that, but that is an excellent question, David. I will get back to you on that question. That is a very cool question. I remember I was pretending to ask, ask blue dwarfs just out of reflex. We've been doing it for 6.5, 7 years. Hey, Terry, great to see you. Hello in San Francisco. Hello from Helsinki. So, I've noticed every time I don't prepare a topic and I just come on like, ask me anything, you all hit me with difficult questions. Like, how does the strong force work? Or what is time? And today, is there a fundamental reason? I love these questions. They keep me on my toes. They keep me thinking. They're brilliant questions. And every time I say, like, today's just going to be an ask me anything, I don't prepare, let's chill. You hit me with difficult questions, and I love that. So do keep the difficult questions coming. I can't guarantee that I will answer many, if any of them, but I do love the difficult questions. Oh, that is still way too hot. You all get to see my live reactions to drinking tea as well, which is always funny. Speaking of logical street numbering, it's one area that the US system is better than the UK. I think a lot of countries have weird systems for numbering streets, for naming streets and for numbering streets. And you just need to figure it out in every country you go to. Like, okay, is it odd on one side and even on another? Does it count up? Does it count down? Yeah, I've taught you enough to be dangerous. Exactly. Yeah, I've given you enough information that now you can hit me with the hard questions. And I love that because, every time I do an Ask Me Anything, there's one or two questions that throw me off. And then I finish and I go speak to my colleagues, like, so I got asked this yesterday. And people are like, "Oof, your audience asks tough questions." Like, yeah, I know, but fun questions. Tough, but fun. Yes. Love the latest images from JWST. Yeah. It's really amazing to see all of the images coming out of the JWST. I don't have Neptune's image here, but we've been getting some really, really cool images. At first we got some galaxies. We got the Carina Nebula, which was spectacular. And I'm just looking for the images. Yeah, the Carina Nebula, this one that we got here, was spectacular. This is an incredible image. This was one of the first ones we got from the JWST, the Just Wonderful Space Telescope. Brilliant image. Really nice to see this infrared telescope taking such detailed images. And we have lately got this really fancy one from Jupiter. So Jupiter in infrared, which looks amazing, where you can really see the northern and southern lights here with this orange glow. You can see the storms, incredible detail. We've also had, of course, the proof of carbon monoxide on carbon dioxide in an atmosphere of an exoplanet. We've had this amazing photo of the quartet. So we have had some pretty cool images from the JWST, the Just Wonderful Space Telescope, already. And this week they released an image of Neptune. And Neptune is really cool because it has rings. And it took us quite a while to figure out that Neptune has rings. Neptune also spins on a slightly different axis to other planets, which is also very, very cool. So yeah, it is amazing to see all of the cool images and science coming out from the JWST. There's just a lot of really cool information coming out, a lot of cool pictures. You know, the pictures are so pretty, but then there's also a lot of science being done. So it is really cool to see the stuff coming out of the JWST. You asked because I heard something about a theory of the leptoquark which unifies two things to explain why the charge are the same magnitude. Okay, I am making a note of this. I'm adding this to the fundamental nature of particles and stuff. And I will get back to you on this, David, leptoquark and fundamental reasons. I will get back to you on this, but absolutely not today. Absolutely not today. But that is an excellent topic. I will get back to this. This is definitely a fun conversation to be had. UK street addresses go up on one side until you get to the end, then keep going up on the way back. Yeah, like up on one side, up on the way back. Best of luck figuring out where to go. Okay, so there is a very nice comment by David Dunn here, which I did want to mention anyway at some point. Tomorrow there is the DART mission taking place. So DART is basically a little probe that we send to space that its mission is to slam into an asteroid. Now, the reason we want to do this is to see if we would actually be able to divert an asteroid very slightly. So hypothetically speaking, if there were an asteroid heading to Earth, would you be able to nudge it into a new orbit? This is part of one of the defense mechanisms that people are thinking about in case of an asteroid coming, like the one that wiped out the dinosaurs. So the DART mission is a first step in this direction. And what it is a little baby probe that is being shot at an asteroid just to see if it can very, very, very slightly alter the orbit of this asteroid. So this asteroid is not heading towards Earth. It's not on a collision course with us. It's just a very good target for this test. So we're going to send this little baby probe is on route, and it's just going to bump into the asteroid and see if it can divert it. And of course, this makes it sound like a really cute thing, right? Oh, we're just going to go up and push the asteroid. It's a suicide mission for this probe. I mean, it's going to fling itself at the asteroid and it's not going to survive the collision. But the cool thing is the whole thing is going to be live streamed. So the images from DART heading into the asteroid right up until the moment of collision is going to be live streamed. This should start in 30 hours from now. So Monday afternoon, I think it starts at 6 p.m. in some time zone. Very helpful of me. 6 p.m. East Coast, I believe. So it will be quite late in the night for me. I believe it's going to be something like midnight or 2 o'clock in the morning for me. But it's really cool because the entire thing is going to be live streamed. So you can basically watch along live, obviously, with some delay as the images get sent to us from DART. But this little probe DART is going to be crashing into an asteroid just to see if it can slightly nudge it, which is very, very, very cool when you think about it. Okay, it was also amazing that Triton was so much brighter than Neptune in the JWST image. It was, yes. Yes, it was really, really nice to see that. You know, the moons were visible in infrared as well, and we got some really, really amazing photos. But I haven't yet uploaded the Neptune image to my image data bank. Okay, so there was another question from Paul there that I'll come back to in a sec. Yeah, Uranus is tilted 93%. It's kind of, so Uranus is on its side. So most of the planets spin kind of in this axis. Uranus is on its side, but Neptune is also pretty tilted as well, if I remember correctly. It's not completely on its side, but it is tilted. It was also amazing that Triton covered that one. Do we think it likely it cannot divert? It sounds like Newtonian mechanics, which I thought was pretty understood. Yes. So it's pretty sure that DART is going to very slightly move the asteroid. This is the objective. Now, it's always a question of will it be enough? Because when something's in orbit, it's kind of in a like a stable orbit. So disrupting it, of course, it's something that we know theoretically should work. We throw an object at another, classical mechanics, something is going to move. So it's something that should work. There shouldn't be any problems. But this is just the proof of principle. Like, if we needed to, would we be able to divert an asteroid, and by how much? So you have to consider the bigger the mass that you're throwing at an object, the more you're going to divert it. So would this little probe be enough to divert the asteroid? Theoretically, we've calculated it. Yes, it should be. But this is what we're going to test. It's always best to test things in action before we actually need them. So Newtonian mechanics is pretty well understood. So there shouldn't be any reason why this mission doesn't work. Technically, tomorrow we are diverting an asteroid and sending it on a new collision course. The Italian CubeSat will take images of the impact. Exactly. There is another Italian Cube satellite around there as well that will take photos of DART on its going yeeting itself into an asteroid mission. So we'll get images from DART and images from the Italian CubeSat as well. Live stream minus the times it takes to transmit. Exactly. Yeah, so Neptune is about 29 degrees off of the tilt. Earth is 7 degrees. So you have 7 degrees is the Earth. Then you have kind of 29 is Neptune, and then you have Uranus, which is on its side, basically. Okay, smash hard enough into an asteroid and you get 2 smaller ones in random directions. Yes. Hopefully we won't be smashing hard enough to actually damage the asteroid in any meaningful way, just enough to kind of nudge it off course, like, hey, go that way. But of course, this is something we have to be very, very careful with, because, the last thing we want is to deal with 50 asteroids because we shot one big one. So this is something that scientists have calculated. There is a bit of uncertainty regarding the exact composition of the asteroids, but it's pretty well understood, and it will be pretty interesting to watch. I might even consider, if it was any other day, I might consider staying up late and watching it. So 23.5 degrees for the Earth. Wasn't the Earth 7 degrees? What? Right. Yes. 23. Yes. Okay. Yes. Earth is on a different. If we compare it to the plane of the Milky Way, it's much more tilted. Yes. Earth is 23.5 degrees, not 7. Yes. I was thinking of something else. Absolutely. Thank you. Yes. Haven't done planetary astronomy in quite a while. I really should recheck this, because I am actually now TAing or tutoring for the course of Basics of Astronomy, but we haven't yet got to planetary physics, so I still have some time to check that. For now, we're doing change of coordinates and fun stuff like that, and interstellar medium, and it's quite fun because I get to tutor and be the teaching assistant on this course, so that's pretty cool. Angle of inclination is 7 degrees. Yes, that is exactly what I was thinking, not the axis on which it spins. Yes, mix those things up. Happens sometimes. Earth is point-like, it's too small. I normally deal with big things. Okay, going back to a nice question that I had from Paul earlier on. Have you ever been in a collaboration, research, or paper where some people have very different specializations? I really like that question. It depends what you mean by very different specializations, right? So I have papers that I've worked with particle physicists, because as I mentioned a lot last week, and as you've heard me say, to understand dark matter, we need to come at it from many different perspectives. And often I will bring the cosmological thing of, okay, I've thrown it at the universe, here's the data that I have. And other times we need to come at it from a particle physics motivation, like, is this model well motivated? How does this fit in with collider searches? So I do have papers where I've collaborated with particle physicists while I'm a cosmologist. So in that case, it's a bit of a different discipline. But I think you're probably asking like a completely different topic that is not physics. And that's something that I actually haven't done myself. I know there are people who do this, who have like really cross-disciplinary topics. Now, the work I do is kind of cross-disciplinary within physics, right? Because we need cosmologists, we need astrophysicists, we need particle physicists. I do a lot of computing, so I speak to some computing experts sometimes. But they're all still within one kind of overarching topic. Now, I know there are some papers where you get a biologist and a physicist as co-authors. I have not been in such a collaboration. I have worked with people who I would say are much more like on the experimental side. I did a short project during my undergrad where I worked with experimentalists actually building a telescope. It was very different from other things I'd done because normally I'm like, I can theoretically tell you how this works. And it was actually hands-on plugging in cables, so that was fun. So yeah, I have collaborated with people who work on slightly different things. And it's always fun how the jargon changes and how something that for me is not jargon for somebody else might be and vice versa. And it's always very interesting to see. It's an example that comes to mind is like the word stochastic. I would say the word stochastic is jargon. I know a lot of people I work with don't think this word is jargon. Then on the other hand, I would say something like thermal is not jargon, and people say this is jargon. So it's always fun when you work with someone who's on a slightly different topic to really try to figure out the common language that you need in order to do the work, to do the papers. And this is one of the reasons I think we should try to reduce overall jargon, because not only does it make it easier for anyone else to understand us, it makes it easier for people in slightly different disciplines to understand each other. So, of course, if I'm speaking to someone who works on exactly the same topic as me, I can throw in a lot of jargon. But once you move to people who are not working on exactly the same topic, the jargon becomes a barrier. And it's also interesting because there's a lot of words you don't even realize you're saying that are jargon. And that's something that my science outreach has helped me for. I always think, like, how would I explain this to somebody in Cup of Cosmology? And which words would I try to de-jargonize? And then I just try to remove the jargon when it's not necessary in general. Stochastic is jargon. Yes. Thank you, David. I agree. The word stochastic is jargon. Not everyone thinks so. So it's interesting. It's interesting to see the different opinions on this. Okay, I know there were some other questions I missed, so going back up the list. There was a comment from Wayne. What is the most distant thing that we are able to detect from the Earth by any method? By any method. The answer to that would have to be primordial gravitational waves. Caveat, we haven't yet detected them, but hypothetically we can. So primordial gravitational waves are gravitational waves formed in the first picosecond, or the first fraction of a second of the universe. They're tiny, tiny, tiny ripples in the fabric of space-time itself that could give us a snapshot of of the stuff happening in the first picoseconds. And this is something that we hope to detect with the future space-based mission LISA, the Laser Interferometry Space Antenna, which is set to launch at some point in the next years. Some years, we never give an answer to that. It's just in the next years, yes. And there's a chance that LISA will measure the stochastic gravitational wave background. So that would be the furthest and oldest thing we can see by any method. Now, of course, this is something we haven't yet done this, so you might consider this to be cheating. We can measure the amount of the elements that were formed in the first 3 minutes after the Big Bang. So this is something that we call Big Bang nucleosynthesis. By looking at galaxies where there's not many new elements, you can get an idea of the elements from the first 3 minutes of the universe. I'm not sure if you would count that as an observation, though it is. It's something that we use, and it gives us a lot of information. Now, if you want to talk about optical light, sorry, not optical light. If you want to talk about using the electromagnetic spectrum, the most distant thing that we can see, the most distant thing we've been able to see from Earth is, of course, the cosmic microwave background radiation, the CMB. This is the oldest light we can see in the universe in any direction we look in the night sky. This is the afterglow of the Big Bang itself. This is a snapshot of what the universe looked like 380,000 years after the Big Bang. So this is the oldest thing we've been able to see using the electromagnetic spectrum. And of course, people knew the CMB was coming here. But yeah, it really depends on what you mean here by what is the oldest thing we can detect, because hypothetically we can detect these gravitational waves from the first fraction of a second. This is what I'm working on. Hopefully we'll do this as soon as LISA launches in N years. Then we have measurements of the abundances of elements 3 minutes after the Big Bang. But if we're talking about actual lights that we can detect, the oldest we can go back is the CMB, the cosmic microwave background radiation. So that is a great question, and I hope my three-pronged answer is a satisfying answer. And as always, thank you for the excuse for the CMB. It took me a full 24 minutes to bring up the CMB today. Come on. I'm not bombarding you with the CMB now. Okay, let's see, more questions, because I know I missed some there. I think that was the setup question to bring up the CMB. It absolutely might have been, and I am fine with that. You know, if you want to give me an excuse to bring up the CMB, I will never complain about that. I will bring up the CMB as soon as possible. Okay, so a couple of people making comments that my students are probably happy with me. Thank you both Davids for that. It's very nice that you make those comments. You know, I really hope that people are happy with the way I explain things, because what's the point of being a scientist if I don't explain what I'm doing properly? And what's the point of being a scientist if I don't teach the next generation of scientists? You know, teaching, TAing, this is an essential part of being a scientist. Supervising, mentoring, this is what we're here to do. This is the reason to become a scientist. So yes, thank you for those comments. I really appreciate those. Okay, astronomers theorize that the axial tilt of planets results from asteroid collisions. Is that true? Maybe. This is a question you should ask David Dunn, because this is very much an astronomy question, and I would say maybe. I would also say that planets are too small for cosmologists, but I think, yes, the axial tilt should be based on different collisions, but, you know, I'm happy to be corrected on that. You're in position now, cafe relaxation. Excellent, James. In a cafe, hopefully with good coffee, asking questions about cosmology. Best way to spend your Sunday. Stochastic is jargon. Yes, I agree. I prefer jargon to be words not used normally. If you said stochastic, people probably know they don't understand it. Yes. Yeah, they might assume wrongly they know what thermal means. I agree with you, David. That is a good point. And just in general, because I threw out the word stochastic and I said it's jargon, stochastic means randomly distributed. So if I have something that I can't say it comes from here, but it comes from everywhere in the night sky, I would call it stochastic. So this is a word that is jargon. I agree, this word is jargon. Were the neutrino detectors built because we already knew they had matter, or to prove that they had matter? Excellent question, James. In fact, let me just make a note of this, because this is a great question that I want to answer, but I think there were some comments towards the things I was just mentioning here. So CMB is the current winner, depends what we define on observation. We use it in economics, but basically it's just posh speak for random. Yes, exactly. Stochastic is basically posh speak for random, and why not just say random? Some people seem to use jargon as a badge of honor. Some people do, and personally, I hate it. Some people use jargon to try to make themselves sound smarter than everyone. Like, oh, look at what I know. Look at me, I use jargon, I must be so smart. No, that's not how it works. And people do this in talks as well. I go to seminars sometimes, and it gives me the impression that people are there to convince you that they know what they're talking about. Like, look at me, I know all the maths, and here's 10 things I derived, and I know all the jargon words. Like, okay, but if you can't explain it without jargon, without math, it tells me nothing. I know a lot of people love using a lot of maths in their talks. Personally, I hate it. Concepts should be conveyed without using mathematics in seminars and talks, and I agree, and the same with jargon. And people who use jargon as a badge of honor are people who do not know what they're talking about in general. Like, you shouldn't need to use jargon to explain your points, and especially not just use jargon for the sake of using jargon. But this is something I have very strong opinions on. What about primordial neutrinos? Okay, yes, we have more neutrinos. Coming back to neutrinos. Okay, different questions about the tilt here, leaving that for... Yes, stochastic is commonly used word, they said sarcastically. Yes. Stochastic is, I don't think it's a commonly used word. Okay, the odd tilts like Venus and Uranus are best explained with collisions early on. Thank you for clarifying that, David. So, okay, on to neutrinos. First of all, we have the comment about primordial neutrinos, which I know was not the first one. So what was the comment, primordial neutrinos? There's lots of comments coming in, and then my questions disappear, but that is fine. What about primordial neutrinos? They should be detected earlier. Yeah, so we hope to measure primordial neutrinos. So primordial neutrinos, they're not really primordial in the same way that gravitational waves are, but in the same way that we have this amazing cosmic microwave background, which is the afterglow of light from the early times in the universe, we might also have a similar background of neutrinos. So in the early universe, at some point, neutrinos stopped interacting with everything else and broke away, very similar to what the photons did. This is something that would have happened earlier than the CMB being produced. So measuring the cosmic neutrino background would give us an earlier snapshot of the universe, not as early as primordial gravitational waves, and not as late as the CMB, somewhere in between. Measuring this background of neutrinos is extremely difficult because neutrinos are really, really, really tiny, barely have any mass, and are very, very, very difficult to measure. So measuring this background of neutrinos is very difficult, but there are hopes that we can do this within the next 15 years. There's one mission called the Ptolemy mission, which aims specifically to detect this cosmic neutrino background. I'm not sure what we will get first, a measurement of the cosmic neutrino background or a measurement of the primordial gravitational wave background. I think both are likely within the next 15 years. I'm actually not sure which I would bet on, like which one's going to come first. I'm honestly not sure which I would put my money on. But I think both of those would be really, really, really cool. It sounds like someone doesn't like math. I don't like math. So I think maths can be really cool. There's a lot of really cool things about maths. And, I use maths all the time. I have to. But I think maths is a tool and not the main part for what we do. There's a lot of people who do a lot of incredible maths, and it needs to be done. But I don't need to see your maths in order to understand a talk. If I want to see the maths, I will go pick up the paper and read it there. But I don't need to see it in a talk. Also, if I'm reading a book and there's a formula, honestly, the first time I read the formula, my brain glazes over. I read a paragraph and it's like, the math changes as this, and there's a formula, and my brain just goes, formula, and skips it. And I have to force myself to go back and read it. So there's this myth that you have to be brilliant at math to be a physicist. This is bullshit. This is wrong. I'm sorry, you do not need to be brilliant at math to be a scientist. I am a computational cosmologist. I get the computer to do math for me, so I don't have to. So I don't have anything against maths in general. I like maths, but it has a time and a place, and its place is not in scientific talks, because unless it's a talk about maths, like you invented a calculus, show me, great. But if I'm listening to something about dark matter, I don't need a whole page of derivation in a talk, because either you're not going to walk me through everything, or you're going to lose people. Just refer me to the paper. Anyway, sorry, rant about that. I have very strong opinions about people putting 5 slides of equations in their talks. The CMB was just a blur. Well, yeah. You know what the CMB looks like, Scott. You've seen it. You've seen it so many times by now. You don't need to see the CMB again. But if you need a reminder of what it looks like, just let me know. I can always send you the CMB so you always have it. At some point I might change this poster for the CMB poster I have, because then I can just go like the CMB behind me. At some point this one might change to the CMB poster. It's right there on my room. Yeah. You can be good at math and still be a working class person. You can be good at math and not use it. You can be bad at math and not need it. Maths is like anything. There are some people are good with it, some people are not, and that's fine. And yeah, anyway, enough ranting about that. There was a really cool question about neutrinos that I wanted to answer. What was the question? Let me just find that again. There was a question somewhere about neutrinos. I wrote it down, but okay. Question from James. Were the neutrino detectors built because we already knew they had mass, or to prove that they had mass? And I love this question. So we have some really, really, really cool neutrino detectors that have proven that neutrinos have mass. We need to go back a bit before, like, why did we do this? So I believe it was in the 1950s or 1920s, in the 20th century, let's just go with 20th century, people were measuring neutrinos. And at this point, we knew how to measure electron neutrinos. So neutrinos come in 3 flavors: electron neutrino, muon neutrino, and tau neutrino. And we were able to calculate theoretically how many neutrinos of a specific type are produced in the sun. Based on everything we know about stellar fusion, we know how many neutrinos should be produced. And there was the homestake experiment in the early 20th century, that was doing exactly this. It was trying to measure how many electron neutrinos were coming from the sun, and this is something that we knew the answer to. However, these people doing this experiment actually found about 1/3 of the neutrinos that they expected to find. And this became known as the solar neutrino problem, that we were only seeing 1/3 of the neutrinos that we needed to. And at this point, people postulated that, maybe the neutrinos have mass. The reason for this is that if neutrinos have mass, they can oscillate between the different flavors. So it could be produced as an electron neutrino in the sun, but by the time it reaches you, it might be a muon neutrino or a tau neutrino. And their detector was set up specifically to detect electron neutrinos. So this led to the idea that maybe neutrinos oscillate between these different flavors, and if they oscillate, they have to have mass, because the mass state mixes with the oscillation state. It's a mass thing that we actually do need mass for. But basically, in order to be able to change flavor, they can only do this if they have mass. So there was already the idea that neutrinos would have mass. So then detectors were built to measure neutrino oscillation and then put limits on the neutrino mass. And this is what we were able to do with Kamiokande and the SNO, the Subdurry Neutrino Observatory. Both of these were able to measure without a shadow of a doubt that neutrinos oscillate and therefore have mass. There was a Nobel Prize awarded for this. So the initial detectors from the homestake experiment that found the solar neutrino problem were not built to measure the mass of neutrinos, but just to measure neutrinos in general, or not built to prove or disprove that they had mass, but just to measure them. Then we saw that actually neutrinos should have mass. So the updated experiments were built to try to prove that neutrinos oscillate and that neutrinos have mass. We're now very sure that neutrinos oscillate. As for the mass, here's the problematic thing. We can only put kind of limits, like if you take all 3 types of neutrinos and add their mass together, here's your upper limit and here's your theoretical lower limit. The difference between the different masses has to be specific numbers, but other than that, we're still trying to figure out the neutrino mass, or the sum of neutrino masses, or the individual, what we call mass splitting, so how the masses are organized. But we know for sure that neutrinos do have mass and neutrinos oscillate. And the latter experiments that got the Nobel Prize for measuring neutrino oscillations were built because by that point we already were pretty sure that neutrinos had mass, and this was the way to prove it. Whenever I see an equation or a chart, my mind gets stuck on what each variable stands for, all the Greeks. Yes. Yeah. This is the thing, right? There's different notation, and even if you're really used to the notation, it takes a minute to think through the equation. There are some people who are very quick with equations, and they see an equation and immediately know this means this. For me, I break it down. Like, if I see an equation, my first process is maths, and then I look at the equation. And what I do first is pull out the things that I know, like this is a mass term, this is a radius. Okay, so the mass changes like the radius squared. This physically tells me something, and then the rest are numbers in front. So what I like to see in maths is like, what is this telling me physically? Like there's some numbers in front, I don't care about the numbers. There's a factor 4 pi, I don't care about that. But like, how does variable A change if I change variable B? Now, this is what contains the physics. And it takes a minute to pull out the physics from a mathematical expression. So if I'm in a talk and there are 20 equations, I don't have time to do this process before we've changed slides. However, if someone just puts up mass changes as density squared, this tells us this, I am on board. Because, I believe you that you've done the derivation. I don't need to see it. Again, I'm sorry for ranting about this, but there are too many talks that get lost in jargon and get lost in maths, and it's unnecessary. Because actually, I'm done ranting and then continue ranting. It adds to people's imposter syndrome. There are a lot of people in academia, myself included, who have very bad imposter syndrome. Of course, imposter syndrome is not limited to academia. A lot of people have this. And if you're sat in a talk, in a seminar, in a conference, on the screen is full of equations, people start thinking like, okay, this is me, it's a me problem. I should be able to understand this. Why can't I understand this? Everyone else can. It must be me. And I can guarantee that 90% of the people in the room at least feel the same way. And I think knowing that, it is speakers' responsibility to make their talks understandable. Anyway, this is a topic that is very easy to get me to rant on. Apparently, that's the rant of the day. Doing training classes at the new job, all things applying okay. Pointed out that the teacher had the wrong answer. Yeah, some teachers don't take well to that. Some should, if a teacher's made a mistake, you should be able to tell them that. If I say something wrong on the stream, I really hope people will correct me on it. You should always call out people. People shouldn't be believed just because they have authority. If someone's doing something wrong, of course, try to call them out politely, maybe discuss it with them, but especially depending if there's power imbalance, if there's a gender issue, so always be careful in the way you point out that people are wrong, but don't just believe that someone's right just because of a position of authority. If planet Uranus didn't have a magnetic field, would it be able to retain its atmosphere? Good question. I think usually a magnetic field is very useful for an atmosphere. I'm not sure in Uranus's case if you could have an atmosphere without it. Given the density of Uranus, you could probably, again, this is a question to ask David Dunn. This is a very astronomy heavy question. Testing your bad question. Well, there are no stupid questions. Put it to the test. There are no stupid questions. Why are neutrinos always moving? Are there neutrinos that are just stationary? Excellent question, and tough question to answer. Now, neutrinos travel almost at the speed of light. They don't travel at the speed of light because they have mass. So neutrinos travel almost at the speed of light. The thing is, neutrinos can travel through almost everything. In fact, everything. We haven't yet found something that you put it here, neutrinos stop. The reason being that neutrinos interact, to our knowledge, only via the gravitational force and the weak force. They don't feel the strong interactions or electromagnetic interactions, which is what prevents my hands from passing through. I don't fall through my chair because of a combination of the electromagnetic force, mainly because of the electromagnetic force, actually, that stops me from falling through my chair, stops my atoms from falling through another layer of atoms. Neutrinos can pass through anything and they travel almost at the speed of light, which means stopping a neutrino is very difficult. And generally, when you produce a neutrino, it's in some type of reaction where the neutrinos have energy. So you have a reaction taking place, and the neutrinos are already produced with some momentum or some inertia. And at that point, it's very difficult to stop neutrinos. So I would say all neutrinos are moving practically at the speed of light, and stopping a neutrino is very, very difficult to do because it doesn't interact with anything that we could say, like, hey, I built a wall, neutrinos can't go past. Again, James, this is not a bad question. As always, there are no bad questions. There are no stupid questions. This is a judgment-free zone. You can really, when I say ask me anything, I mean you can ask me anything. There are no bad questions. There are no stupid questions. So really go ahead and ask me anything. And this question about neutrinos is definitely not a bad question. It's a very, very interesting question. Some more questions here about, answer from David Dunn about the atmosphere. It's all about gravity and temperature and not so much about the magnetic field. Great, so we don't need a magnetic field to have atmosphere. Perfect. Thank you for that, David. That was related to a question about why Mars lost its atmosphere. Okay, gravity does help there. If I see that you're tagging each other, I'm just going to skip it now because then I can carry it on with my main questions. It just requires that those building bridges are good at math. Yes. I hope that the engineers designing things are good at maths. For some people, maths is essential. I use maths a lot in my work. All of my computer codes are based on the equations that me or others have implemented. But if you give me a new equation and say, implement this in your code, it's going to be like, oh, give me a minute to understand the equation so I can understand how to tell the computer to solve it. So there are varying levels. Of course, I use math every day, and for some things I have to be good at maths. And if you give me the equations of motion of a species in the universe, I know what to do with them. But this is the thing, I know how to do my maths. The people building bridges know how to build bridges. But if you're telling me about a new topic, don't tell me with your maths, tell me with your words, and then give me the maths afterwards. Anyway, yes, again, this topic, ranting. Good topic, though. Excuse me, your math is wrong. Good job. Yes. Maybe don't phrase it quite like that. It's like, is it possible? Or you can even ask, I'm not quite. I don't really see where this last expression comes from. Could you explain it, please? And then, I've had people do that to me, like, where did the minus sign come from there? And I look at it like the minus sign came from me making a mistake. So, it's okay to ask people where their maths is coming from. Yeah, so I keep saying, like, ask David these questions. So, David Dunn does have his own show, the astronomy show, over on Twitch these days, I believe. So, all of your astronomy questions, be sure to follow David Dunn and ask him directly, because David can answer the astronomy questions much more than I can. Okay, I'm caught up with the comments. Awesome. I hope I didn't miss any. If I did, please do ask them again. And I like that I write down questions and then I just write vague things like why neutrinos. But I think I've answered the questions that were just why neutrinos. Yeah, sometimes my comments are not overly helpful. I was just staring at my piece of paper, why neutrinos? I think I answered the why neutrinos question. Now can we discuss math versus maths? Maths is plural. There should be an S on it, okay? As far as I'm concerned, maths is plural. You say mathematics, you don't say mathematic. Me, personally. It's an American versus British thing. Now, for me, maths makes a lot more sense. However, I have been around enough people who say math that I now use both. And sometimes I'll say math, sometimes I'll say maths. The S belongs there. In my opinion, maths makes more sense. But I am used to people who say math. So some days I say math, some days I say maths. At the end of the day, it doesn't matter as long as as long as we all understand each other. It doesn't matter if you say math or math. It's a matter of preference. And yeah. Minus sign magic, yeah. Sometimes in equation you look at like, this would make a lot of sense if there was a minus sign in front. Yeah. Sometimes plus minus signs, they come and go. But yeah, sometimes a minus sign is important. Like if you're going up or down in a rocket, minus sign is important. If you're interested in the overall velocity, if it's traveling left or right, doesn't matter. You just take the absolute value. So sometimes the minus sign, but sometimes it's useful. Yeah, question from James. I heard that as mass objects approach the speed of light, its mass increases. Does this mean anything that moves cannot be measured correctly? Very, very nice question again. So, of course, we do have Heisenberg's uncertainty principle, right? That the faster an object is traveling, the harder it, or you can measure an object's velocity, you can't measure its momentum and like its position or its velocity. So you can measure one or two of those. You can't measure both. So if you tell me very, very precisely where a particle is, you have no idea how fast it's traveling. And if you tell me how fast it's traveling, you can't say it's exactly here. But if you try to accelerate an object to the speed of light, it will gradually have issues with its mass. You cannot accelerate something to the speed of light because you need to put so much energy into the system that at some point you're basically adding mass. So there's a difference here between an object traveling close to the speed of light and an object being accelerated to that point. Neutrinos, for example, travel almost at the speed of light. They have a specific mass. Now, if you try to accelerate them to the speed of light, that's where you'd have issues. Like if you try to accelerate a human to the speed of light, you'd have problems because of our mass. This is why if something travels at the speed of light, we know it must be massless, because else you'd have a lot of issues. Photons travel at the speed of light, massless. Gravitational waves travel at the speed of light, bad example. We're still trying to figure out how that fits together. But neutrinos, we thought traveled at the speed of light, and then we realized they have mass, which means they cannot travel at the speed of light. So does that answer your question, James? It is true that if you measure that something's velocity, you can't know its position, and if you measure its position, you can't know its velocity. Talking about quantum particles, of course, you can't use this as an excuse to get out of a speeding ticket. Like, sorry, I don't know how fast I was traveling, but I know exactly where I am. Please don't try that. Um, but yeah, in general, you can measure either a particle's velocity or its position. You can't measure both. And you can't accelerate something to the speed of light because then you have issues with its mass. I hope that answers your question, James. If not, please ask again. Math is jargon for maths. Yeah, maths doesn't matter as long as you know what you're doing. Same with data. As Ben is just pointing out here, is data plural or singular? Technically, scientifically speaking, we use data to be plural. The data are telling us this, but it's just so much more natural to say the data is telling me something, right? Sometimes I write the data is, and then I look at it like, wait, no, this is supposed to be plural. The data are telling me. Yeah. I get caught up on that one as well sometimes. Maths all the way, or insist on the apostrophe, math. Yeah. Now, data as a singular noun, another cause of pointless pedantry. Exactly. It's just being pedantic. And as long as we understand each other, it doesn't matter. So, if you want to say the data is telling me, I won't complain. Now, the problem is in a scientific paper, usually we need to be precise. So then we try to use the plural. But in conversation, I will often refer to data as singular. I will often refer to it as plural. At the end of the day, it's semantics, and as long as we understand each other, I don't think it's worth being pedantic about these things. I've changed a lot about this. 5, 6, 7 years ago, I was super pedantic, like grammar exists for a reason, punctuation exists for a reason. No, it's fluid. Language is fluid. Language changes. We invent words every week, Language is a tool designed for communication. If you're getting lost in the rules and losing the points, that's not the case. Language is a tool for communication. If you want a semicolon there, put a semicolon. I'm pedantic on my own writing, but I will not care about being pedantic with other people's writing. Like, I will be critical of my own writing. You can write however you want, as long as we understand each other. You want to say data is, I will not correct you on it. Okay. Thank you for joining, Paul. It's always great to have you here, and thank you for the fun questions and fun topics as well. It's always great to have you here, Paul. Thank you for joining, and sorry that you'll miss the end. Lieutenant Commander data is singular. Yes, indeed. Lieutenant Commander data is singular, and if we get into Star Trek, then we will use the singular one. Words are hard. Yes. We have government minister issuing instructions about grammar. Good for them. I think language is beautiful. I love communicating. I love language. I love reading poetry and stories and creative use of words. It's great. And if you take the creative liberty to drop a punctuation mark, fine. If you want to tell me a story and you need data to be singular, fine. Being pedantic about language is pointless. Unless it's literally your job to be pedantic about language, fine. If you are officially a proof editor who wants to be pedantic, fine. But in general, there's no need to be pedantic. Anyway, that's also something that apparently I have opinions on. I have opinions on a lot of topics, and it's very easy to get me to rant about topics, such as whether maths belong in slides, the answer being no. Data is the plural of datum, a word I use in my field all the time. Yes, but also, yes, technically it is correct that the data are plural. Does it matter? No. It matters to some people, fine. Doesn't matter to me. But yeah, YouTube by itself is a social medium. Yeah, it is a social medium, and we combine them together to say social media. Yeah. This is the thing. Language is in flux. Language is changing. Sometimes we need new words. We invent new words. Sometimes we discover something new. We find a new word for it. The language changes over time, and adhering to rules from 50 years ago makes no sense today. Is Finland dog friendly? Finland is very dog friendly. There are so many dogs. I went out for a walk in the forest today, and I think we saw 7 different dogs. It's lovely. Not all of them are huskies. There's a lot of different breeds here. I have seen a fair amount of huskies, which is always nice in winter, like seeing a husky out in the snow. It's like, yes, this is where they belong. But Finland is very dog friendly, and I like it. My building at work does not allow dogs, and apparently there's a story of a golden retriever getting in and wreaking havoc in the student rooms and knocking stuff over. And the next day, after this golden retriever was there, signs appeared on the door saying no dogs allowed in the building. So my office building is not dog friendly, but overall it's very dog friendly here. I think also because there's just a lot of nature around here. Like I live in a very nice area. It's not like a posh fancy area, it's just a pretty area. And I can walk in 3 different directions and find myself in a forest within 5 minutes. So it's very easy if you have a dog to find a place to walk the dog. Like I could literally from my place, that way there's a forest in 5 minutes, that way there's one in 5 minutes, that way there's one in 6 minutes. So it's very, very easy to find nature, which means it's very easy to find a place to go walk your dog. And I love it because I love dogs. I love all animals with 2 exceptions. Like the 2 animals I don't like are wasps and ticks. Otherwise, I love all animals. So seeing a lot of dogs around is very nice. There's actually a lady in my neighborhood who has a cat and she walks her cat on a leash. And I've sometimes seen the cat out on a leash. It's really funny. Agree with mathematics being plural and math being wrong, but it sounds weird to me after hearing and using it my whole life. Yeah, it's American versus British. Some people say math, some people say maths. My English is all over the place. Sometimes I'll throw in Spanish words, sometimes German words. Doesn't matter. As long as we understand each other, it doesn't matter. That said, I try not to throw German words in when speaking to people who don't speak German, of course. Just fun because I've also now picked up a couple of words of Finnish, and I'm not yet at the stage of just slipping Finnish into my sentences, but someday I'll be there. That will be nice. Okay, so we are almost at the 1 hour mark, which means it's almost time to wrap up the stream. So a few short announcements. Next Sunday, 2nd of October, it's quite likely that I won't do a stream. Forest has a jargon meaning too. Technically, it's a game preserve for deer. Okay, that is good to know. It's good to know that there are jargon words that I don't know about. Of course there are. It's always fun to learn new jargon. Every jargon has a time and place. Adding fleas, mosquitoes, and bedbugs. Mosquitoes are an important part of the ecosystem. Fleas, yeah. It's just like I have a very, very strong dislike of ticks, and I am afraid of wasps. So those are 2 animals. That's a big no for me. But any other animals, like I can coexist with them. Thinking about a cat on the leash is hurting my head. Yeah, it's really funny. So I think if you're going to have a cat that goes outside, it should either be on a leash or under constant supervision because it's a predator that shouldn't be in that ecosystem. Yes, back to topic. Thank you, David. Yes, cats on leash, funny. Thank you for cutting me off from that rant there. So no show next week. Probably not. So I'm kind of busy these days with grant deadlines, and I've been working too much. I've been not resting enough. And my next big deadline is Wednesday. Thursday I have teaching, but then I'm taking a 4, potentially 5-day weekend. I'm taking the Friday off, the Monday off, maybe the Tuesday off. And in those 4 days, I plan on doing nothing other than resting, being out in the forest, going out for food, and absolutely nothing else. So in keeping with doing nothing except chilling, there will be no cup of Cosmology on the 2nd of October. I will be resting, recovering, and getting energy to do the next grant. Then the week after that, on the 9th of October, I will have a guest. And the week after that, I have another guest. So to recap, next week, probably no stream. I might decide at some point, like, yes, let's randomly do a stream, but probably not on next Sunday. And then the 2 weeks after that, we have guests. So 2nd, no, is it the 2nd or the 3rd? Let me just check that. 2nd, no stream. 9th, I have a guest. We'll be doing general relativity, fun topic. And 16th of October, I'll have a guest. We'll be talking about something very fun called cosmological bootstrapping. So you have that to look forward to. So no stream on the 2nd, guest on the 9th, guest on the 16th, probably, unless there's any last minute change of plans. How can we find David Dunn? David Dunn is on Twitch, at David Dunn 1966 over on Twitch for the astronomy show. I think it's every week, but not this week. Suspect it's only a small subset of wasps you are scared of. Yeah, if it's yellow and black, I don't like it, except bees because bees are cute. But yeah, if it's yellow and black and buzzes at me, there's a high chance I won't like it. What is grant work? Is this explanations to donors you progress? Okay, this is a great question, James. Thank you for that. Yes, I did mention grant, so I should specify. So there's always a problem in academia figuring out where your next position is or where your next salary is coming from. There is, I'm currently a postdoc. This means I'm not tenured. I'm not a professor. I'm also not a student. I'm somewhere in between. And most postdoctoral positions are for 2 or 3 years. So we work for 2 or 3 years, then we change to another group, whoever has money. You look at job descriptions, you find somewhere that's advertising for a postdoc, like, hey, we need a postdoc, you apply and you try to get the position. Of course, it doesn't add much job stability because you only have the position for a fixed amount of time. There are grant agencies that give money for specific projects. And if you have your own grants, of course, it's pretty easy to get a position in a university because then you go like, hey, I have my own money, can you give me an office? So getting a grant is something that allows you to do more research and takes away a bit of the job insecurity. There are a lot of different grants you can apply for. Like you might apply for a grant to go traveling, and this will come from a specific agency. You might apply for a grant to fund a specific project for 2 years. Now, I decided that I would like to stay in Finland for as long as possible. So I'm applying for different grants that would allow me to stay here longer. So my position here is for three years, like 3 years, and I'm applying for grants to get my independent money that would then let me stay here longer. So I'm applying for 3 grants. One is for 2 years, one is for 4 years, one is for 5 years of funding. They each have different conditions. They each have different things that they focus on. But it's writing a document with all the different requirements they have, basically trying to convince this agency that my project is worth spending money on. Now, a lot of these are like European projects will say we're going to spend this many billion euros on projects this year. So then thousands of people apply. They rate everyone, like this is the best proposal, this is the second best. They rate everyone, and then they go down the list, funding all of the ones until they run out of money, and that's where they stop. I'm applying for several different grants. So yes, grant work is writing the application, basically convincing people that I'm awesome, my project is awesome, please give me money for it. It's tiring, it's exhausting, but it's part of the job, and I've also learned a lot by doing these grant applications. So I could do a whole stream about grant applications, but that's the short version of what is grant work and what do I mean when I say I'm writing grants, and the reason why I'm taking 4 days off next week after the next grant deadline is Wednesday. But it's mostly done. Like the grant deadline is Wednesday, it's mostly done. I'm okay with that. Do you have to become a citizen in each country you work in? I have to become a legal resident. I don't have to apply for citizenship. So I currently have a resident, especially since Brexit, where I'm no longer an EU citizen. So before it was easy, I would just move because I was European and I had the right to live and work in any European country. Because of Brexit, I am British. I no longer have the right to live and work in European countries because the UK decided they were better off on their own. So I actually had to apply for a visa to come and live in Finland. I have a residence permit here because I have a work contract. If I move country again, I'll need to apply for a residence permit in another place. So I become a resident in every country, but to become a citizen, you normally need to live in the country for somewhere between 5 and 10 years. You need to kind of be committed to the country. Maybe someday I'll get Finnish citizenship. We'll see. That's the long-term plan. Okay, thank you for these very good questions about grants, about citizens. We can also talk about all of these. I'm always very open about academia, about moving about. So all of these questions are very welcome. But we have now passed the 1 hour mark, so I'm going to wrap up the stream today. Probably no stream next week, then guests for the 2 following weeks. So I will be back online at the latest in 2 weeks, unless I randomly jump in next week. Brexit sucked. Yeah, who could have seen that coming? Wow, never saw that coming. Yes. So thank you everyone for joining. This has been great fun, some really cool questions. I have a note to look at the theory of lepton quark and the fundamental properties of the electromagnetic force. It's on my notes. So thank you everyone for joining. This has been really, really fun. I hope to see you all again in time for the next stream, which will be at the latest in 2 weeks. And I hope in the meantime, you all stay safe and take care of each other.